So here we will be having a 2 degree of freedom robot, so that is a manipulator. So you will be having a 2 degree manipulator like this. So like this. Okay, this is y-axis, this will be x-axis. So the manipulator arm is in downward direction. So you will be having this is theta, and this will be, the action will be in the direction of theta. So it is tau 1. So you will be having theta 2, and the action will be like this, tau 2, and the length will be L1, and this length will be L2. Okay, so you will be having so the first thing that we have to do is we have to calculate the, so in order to calculate the Lagrangian equation for this 2 degree freedom manipulator, so you have to calculate the first the kinetic energy. So the Lagrangian equation is nothing but kinetic energy minus potential energy. Here the mass is completely concentrated at the end point. So here the point A, and this will be the point B. Okay, so it is concentrating on these two conditions. So the first thing that we have to do is we have to write the coordinates of A and coordinates of B. Okay, the coordinates of x a and x, so y a. So you will be getting the coordinates like this, L1 sin theta 1 and minus L1 cos theta 1. Okay, so this will be sine and this will be cos. So because you are having theta here, so L1 sin theta 1 and minus L2, because it is in downward direction, so you will be getting as minus L1 cos theta 1. Okay, so next, so the next coordinates, that is with respect to B point, so you will be getting as L1 sin theta 1 plus L2 sin theta 1 plus theta 2. Okay, so next YB, so L1 minus L1 cos theta 1 plus or minus, sorry, minus L2 cos theta 1 plus theta 2. Okay, so these are the coordinates of point A and point B. Okay, so we have to do the differentiation. So for after doing differentiation, so you will be getting the values. So in order to get the velocity, you have to do the differentiation. So you will be getting as L1 cos theta 1 and minus L1 sin theta 1. Okay, this will be theta dot 1 and theta dot 1. Okay, so you will be getting getting the velocity equation for this will be, so you will be getting as L1 cos theta 1 dot I theta 1 dot L2 cos theta 1 plus theta 2 into theta dot 1 plus theta dot 2. Okay, similarly L1 sin theta 1 theta dot 1 plus L2 sin theta 1 plus theta 2 into theta dot 1 plus theta dot 2. Okay, so you will be this is the velocity equation. So we have to go for velocity square, that is you need to do modulus square, because the kinetic energy formula is mv square half mv square. So as the mass is concentrating at the points, okay, at the end points, so we have to do the velocity square. Okay, so velocity square is nothing but you have to square the both the things. Okay, so after square going for modulus square, so you will be getting, so we have to do both the things. So I have got an answer of L1 theta dot 1 square plus L2 square theta dot square plus theta 2 dot square plus 2 theta 1 theta 2 plus 2 L1 L2 cos theta 2 theta 1 square plus theta dot 1 dot 2. Okay, so this is the velocity square equation. Okay, so next we have to substitute the value of half mv square. Okay, so next we are just concentrating on second link. Okay, the first link is still to be solved. Okay, so just give me some time, I will tell you that also. So k2 is equal to half m2 v square or v2 square. Okay, so half m2. So as the mass is concentrating at the end points only, so v2 square, so we will be substituting the whole values. Okay, so entire thing will be substituted here. Okay, L1 square theta dot square plus half of m2 L2 square theta dot square plus theta 2 dot square plus 2 theta dot 1 2 theta dot 2 plus half of m2 2 L1 L2 cos 2 theta 1 square plus theta 1 theta 2. Okay, so this is the k2 equation. So for calculating the kinetic energy, we have to go for k1 plus k2. So the k1 is nothing but half mv square. So v square for the first link will be, we will be getting as, so for calculating the v square for first link, we will be getting as so that we have already seen in first that is 1 degree freedom manipulator. So we'll be getting as L square theta dot square. Okay, so we'll be substituting that. So half of m1, so m1 plus m2. Okay, into L1 square theta dot square 1. The rest of the thing will be this one. Okay, so half of m2 L2 square theta dot square plus theta dot square 2 theta dot 2. Okay, plus m2 2 L1 L2 cos 2 theta dot 1 theta dot 2. Okay, so this is the kinetic energy equation. Similarly, we have to find the potential energy. Similarly, we have to find potential energy. So the potential energy P1 is equal to minus mg, height will be L1 cos theta 1. Okay, so that's what we will be having. So from here minus L1 cos theta 1, and this will be minus L1 cos theta 1 plus minus L2 cos theta 1 plus theta 2. Okay, so that's what we are going to do. So potential energy will be cos 1, and potential energy second link will be m2, this will be m1 g L1 cos 1 minus L2 cos theta 1 plus theta 2. Okay, so this is the potential energy. Now we have to substitute the entire thing, kinetic energy and potential energy, in the equation kinetic energy minus potential energy. So entire potential energy P is equal to, you will be getting an answer of P1 plus P2 is equal to minus m1 plus m2 into g into L1 cos theta 1 minus m2 g L2 cos theta 1 plus theta 2. Okay, So this is the value of potential energy. Okay, now substitute the entire thing in the Lagrangian equation. So you'll be getting as half of m1 plus m2 L1 square theta dot square 1 half of m2 L2 square theta dot 1 square theta 2 dot square plus 2 theta 1 theta 2 dot plus m2 L1 L2 cos 2 theta dot square 1 theta dot 1. Okay, the entire thing I will be writing the entire thing. Okay, plus m1 plus m2 g L1 cos 1 plus m2 g L2 cos 1 cos 2. Okay, this is minus, as it is minus, so it will be converted into plus. Okay, so just the entire equation is this. Okay, so we have found out the Lagrangian equation. So we have to find the derivative of Lagrangian equation. So in order to find the derivative of Lagrangian equation, we have del L by del theta dot 1 first, next d by d theta of del L by del theta. So we need to find out del L by del theta dot 1 first. Later we have to find del L by del theta dot d by d theta. Later we have to find del L by del theta 1. Okay, so first, so we have to find the first derivative. So we have to calculate theta 1 dot ఎక్కడైతే ఉందో అక్కడ మాత్రం డెరివేటివ్ చేస్తే సరిపోద్దండి. సపోజ్ ఇక్కడ చూడండి, సో టీటా 1 డాట్ ఉంది. ఓకే, సో ఇది డెరివేటివ్ చేస్తే సరిపోద్ది. అలాగే సో మనం ఎక్కడైతే టీటా 1లు ఉన్నాయో అక్కడ డెరివేటివ్ చేస్తే సరిపోద్దండి. ఓకే, సో ఆఫ్టర్ డెరివేటింగ్ దట్, సో ఐ హ్యావ్ గాట్ అన్ ఆన్సర్ ఆఫ్ m1 ప్లస్ m2 ఇంటూ L1 స్క్వేర్ theta dot 1 plus m2 L2 theta dot 1 plus theta dot 2 plus 2 m2 L1 L2 cos 2 theta dot 1 plus m2 L1 L2 cos 2 theta dot 2. Okay, later we have to go for derivative of d by d theta. So we have to go for the derivative with respect to time. Okay, now m1 plus m2 L1 square plus m2 L2 square plus 2 m2 L1 L2 cos 2 theta double dot 1. So we have to know how to get the derivatives of these terms. Okay, so I am just giving you the answers because I was thinking like the derivative part. Okay, so I am just explaining the what is the Lagrangian equation, how we have to do that. Okay, so in order to derive the equation of motion, you have to do first Lagrangian equation. After that you have to go for the derivative of the Lagrangian equation. Okay, so just write that m2 L2 square plus m2 L1 L2. So just check with your answers and let me know if I did anything wrong in anywhere. L1 L2 sin 2 theta dot m2 L1 L2 sin 2. Okay, so only theta, where theta is there, then there only we have to do the derivative part. Okay, okay, del L by del. minus m1 plus m2 gl1 s1 minus m2 gl2 s12. Okay, so this is the complete equation. Okay, so you have to substitute that value in torque. Okay, so in order to find the torque, we have the equation like d by d theta, sorry, d by dt into del L by del theta dot minus del L by del theta. Okay, so this is the finding the torque for first link. Okay, సో ఫస్ట్ లింక్ యొక్క టార్క్ ఫైండ్ అవుట్ చేయడానికి ఇది, అలాగే సెకండ్ లింక్ ఫైండ్ అవుట్ చేయడానికి మళ్ళీ డెరివేటివ్ చేయాలండి. సో సేమ్ లగ్రాంజియన్ ఈక్వేషన్ మళ్ళీ డెరివేట్ చేయండి. సో డెరివేట్ చేయాలంటే యూ హ్యావ్ టు కీప్ దాస్ డీటా 2. ఓకే, డి బై డి theta ఆఫ్ del L by del theta dot 2 minus del L by del theta 2. Okay, so for torque 2. Okay, so you have to find that also. Okay, so just find out both the things and let me know the answers. Okay, so ఇది మీరు చేయండి అన్న. ఓకేనా, సో ఇది చేసి నాకు ఆన్సర్ చెప్పండి. లేటర్ విల్ గో ఫర్ అనదర్ టైప్ ఆఫ్ మోడల్ ఇన్ 2 degree of freedom. So after that we will close the Lagrangian equations and we go out for Jacobian equations. సో జకోబియన్ వచ్చేసరికి ఇంత కన్ఫ్యూజన్గా ఉండదండి, చాలా క్లియర్గా ఉంటుంది. డోంట్ వరీ, జకోబియన్ ప్రాబ్లమ్ సాల్వ్ చేయడం లిటిల్ బిట్ ఈజీ. ఓకే, వెన్ కంపేర్ టు Lagrangian equations. ఓకే, ఓకే అండి, థ్యాంక్ యూ.